Okay,
Ew, that's nasty.
Don't put that.
so the stuff we're talking about today follows up on the same stuff that we did on Tuesday. Okay? Dealing with proportional parts in these triangles. So again, this is the same stuff we talked about on Tuesday. Whenever you have two lines that are parallel, or where there's a line inside of a triangle parallel to one of the sides that splits it proportionally. Like this says right here, AB is to BC is AE is to ED. Okay, so on this it says ST is parallel to RQ. It says that PT is 7.5, TQ is 3, SR is 2.5, and we're looking for PS. Okay. So again, since those two lines are parallel right there, it splits it proportionally. So X is to 7.5, as 2.5 is to 3. All right. So 7.5 times 2.5 is what? 18.75. X times 3 is 3x. Divide both sides by 3. That means x is what? 6.25. Okay. Next one is the same thing. PS is 12.5. PT is 15. Whoops, I missed that. SR is 5, and we're looking for TQ right here. All right, so again, these two lines are parallel, means it splits it proportionally. So 12.5 is to 5, as 15 is to X. So we get 75 equals 12.5x. Divide both sides by 12.5. And what does that give you? X equals 6. Okay, so like I said, that's really the same stuff that we did on Tuesday. So the one little thing we're going to throw in that's new today is talking about this idea of a mid-segment, okay? So a mid-segment of a triangle is a segment with endpoints that are the midpoints of two sides of the triangle. And every triangle has 3 mid-segments. Okay, so what that's saying is this. All right, so if you look at this whole side AC right here, okay? Looking at that whole side there. The midpoint of that segment is R. Okay? Down here on the bottom, all the way from C to B, the midpoint of it is Q. And on the other side over there on side AB, P is the midpoint of those two. Okay, so where you connect those two midpoints, that right there is what we call a mid-segment. So where the two midpoints of the side are connected is called a mid-segment. And like I said, every triangle has 3 of those. All right, so there's 2 things about a mid-segment. Number 1 is that it's parallel to a side, okay? So it's parallel, but the other main thing is that the mid-segment is half the length of the side it's parallel to. All right, and so that's what this says right here. Mid-segment of a triangle is parallel to one side, and it's 1/2 the length of the side. So, for instance, if FG here is 30 centimeters, how long is JK, that mid-segment that's parallel to it?
15.
It's 15. It's half of that. Which, I mean, really just common sense. Makes sense. The mid-segment's half of the side that it's parallel to. Ready? So on the back, it says XY and XZ are mid-segments. XY and XZ are mid-segments. Okay, so the first one there asks for the length of XZ. So XZ is a mid-segment. What side is it parallel to?
RT.
To RT.
6.5.
And it's half of RT. So RT is 13, so how long is XZ? 6.5. It's half of 13. Right, it's just 13 divided by 2. 13 cut in half. So that's 6.5. Okay? B asks for the length of ST, so that's this whole side over here. So what's the mid-segment parallel to that one?
XY.
Is XY, right? This is the one parallel to that.
214.
Now I'm going the opposite direction. I know the mid-segment is 7 in length, so how long is that side it's parallel to?
40.
It's got to be twice that, so ST is just 14. All right, and then on the last one there, C is asking for angle RYX, which is this angle right here. So if you think about it, this line is parallel to this line. We've got this like this. So how big is that angle RYX right there?
121.
Yep. And how do you know that?
Alternating.
Good. Because alternate interior angles of parallel lines are congruent. So that angle is just 124 degrees. All right, next one. Asks for the length of DE, so right here. And DE is a mid-segment because D has to be the midpoint since that's congruent to that, and same thing down there with E. So DE is a mid-segment. So how long is DE? Yep, it's half of this side right here. Half of 15 is 7.5. All right. Next one is asking about DB, which is from here to here.
42.
Yeah, because this mid-segment is 9.2 right here. So the whole thing over here is that doubled, which would be 18.4. But DB is half of that. So really it's just congruent to this piece right here. So it's 9.2. And then angle FED is going to be 82 degrees. Okay? Now this last part, proportional parts of parallel lines, this is really the exact same thing as it is with the triangle. Okay? When you have these lines are parallel, it says that it splits those proportionally. So you can see AB is to BC, AB is to BC, as EF is to FG. All right, so let's drop down to this one right here. Okay, so these lines are parallel, so it splits this proportionally. So 7x minus 2 is to 4x plus 3, as 8 is to 8. All right, so there's a couple things going on there, but we can just solve it like that. Okay, so we can just cross multiply, but I do want to come back to this after we get done and talk about this a little bit more. So let's just cross multiply. 4x plus 3 times 8 is what? 32x plus 24 equals, what's 7x minus 2 times 8? 56x minus 16. All right, so I'm going to subtract 32x from both sides. So we get 24 equals 24x minus 16. Add 16. That zeroes out, so 24x equals 40. Divide by 24. And so 40 divided by 24 is either 5/3 if you leave it as a fraction, or as a decimal, 1.66 repeating. Okay, now I want to go back up here and think about this again. So 7x minus 2 is to 4x plus 3, as 8 is to 8. Okay, so there's something a little bit strange going on there. What's kind of the 8 over 8, right? 8 over 8. So what happens when you have anything divided by itself?
1.
Is 1, right? So 8 over 8 could be written as, well, it could be written as just 1, but it could also be written as 1 over 1, right? You could simplify 8 over 8 as just 1 over 1. And so it could be like this. 7x minus 2 is to 4x plus 3, really as 1 is to 1. Then if you were to cross multiply, what is 4x plus 3 times 1?
4x plus 3.
4x plus 3. And what's 7x minus 2 times 1? 7x minus 2. Then if you work that out, you're going to get the exact same thing. You're going to get x equals 5/3 on that. Okay? So we need that idea to help us to solve a problem like this one right here. Okay. So these two are going to be parallel to each other. They're both 90 degrees. So corresponding angles are congruent, then the lines are parallel. So it splits it proportionally. So I know 2x plus 1 is to 3x minus 5. Okay, now here's the problem. I don't know how long this piece is from here to here and this one from here to here, but I do know that however long they are congruent to each other, right? So it doesn't matter. I could put, who knows? I could say that this is 40. And if that's 40, that would be 40, right? So if I put 40 over 40, what does that turn into? 1 over 1. It doesn't matter what this is. It could be 60 or 60. I don't know what it is. We could find it, but it doesn't matter. It's going to be 1 over 1, whatever it turns into. So on this, it's going to be basically be 2x plus 1 is to 3x minus 5, as 1 is to 1. And so when I cross multiply, what am I going to get? 3x minus 5 equal to 2x plus 1. Okay, and then from there it's just simple. It's taking 2x away from both sides. X minus 5 equals 1. Add 5. And so x equals 6. Okay, so there's going to be several places on your assignment where this is going to show up, where you're going to have to think about that. You may not know how long those are, but it will show that they're congruent, and you're just going to apply this fact right here when you see that.